Multiplying and dividing rational expressions. First, defining a rational expression. A rational expression is a fraction whose numerator and denominator are non-zero polynomials. And in simplified form, it just means the numerator and denominator have no common factors. So for instance, everyone's familiar with simplifying 8/12. Okay? The factors of 8/12 or the factors of 8 are 2 times 4, or we could break that 4 into a couple more 2s, 2 times 2 times 2. That's the prime factorization, using only prime numbers. And then 12 would be 3 times 4, right, which we could break that 4 into 3 times 2 times 2. Okay, now really, these are all factors of 8, all factors of 12. Well, the common factors are 2 and 2. So we cancel those out, and we're left with 2/3. Now, I realize that's not usually how most people do that. They say, well, what goes into 8 and 4? Well, 4 does. 4 goes into 8 twice, and 4 goes into 12 3 times. Well, here's the 4 you're talking about. You take it out of each of them. Okay? Now, this concept right here, though, is helpful when you're simplifying rational expressions. If we take a look at these, first you want to look at your fraction and see if the numerator and denominator are both, if they're both simplified, or if they're both factored, I guess is the best way to say that, not simplified. They're both factored. And the way we do that, the quick way is just say, well, are there any addition and subtraction symbols? Okay, notice this first one, no addition and subtraction, no addition and subtraction. That means 54/12, or 54x to the 4th over 12x, really is the same thing as having 54 over 12 times x to the 4th over x. Right? So you could simplify both parts of those, like simplify the numeric part and then simplify the variable part. 54 and 12, what goes into both of those? Well, 6 does. 6 goes into 54 9 times and into 12 twice. And what goes into x to the 4th and x? Well, obviously x does. What I like to think of is, where do I have more x's? Okay, I have 4 x's here and 1 x here. When I say 4 x's, it means x times x times x times x, right? I have 4 of them, and I only have 1 down here. Well, this 1 cancels 1 up there. I'm left with 3 of them up there. So really, when I'm doing that, I end up with 9 over 2, and on top I have x to the 3rd still. I have 3 more x's up here than I did on bottom. So I think, well, I'm going to have x to the 3rd. All right? Now, if I'm looking at, say, this problem, and this next one here, the first thing I recognize is the denominator isn't factored, right? I have a subtraction symbol. So I need to get this into a factored form if I can. What number goes into 15 and 10? Well, that would be 5. So this becomes 5, and 5 times what's 15x? Well, that's 3x. And 5 times what's 10? That is 2. Okay? And so on top, I have 20. So notice now I have two things I'm multiplying on bottom. I have 5 times this parenthesis set. Now this is a factor because I'm multiplying it. Okay, so anytime you have addition and subtraction inside parentheses, we just kind of ignore it. It's like having a box of these things. And the only way you can cancel out this 3x minus 2 is if you had a 3x minus 2 on top. Okay, so really what I'm looking at is 20 over 5, and then times, looks like I have a 1 over 3x minus 2. Now we don't write it like that. Okay, we really just kind of write it with this and get rid of that. And we think to ourselves, 20 over 5. Well, what does that reduce to? Well, 20 divided by 5 is 4. Or 5 goes into 5 once, and 5 goes into 20 4 times. So I'm left with 4 on top, and just the 3x minus 2 on bottom. And you could put the parentheses or not. Usually you won't see it with parentheses. All right. Well, this next piece here, this next one, notice I have addition here, and I have addition and subtraction here. I'm going to try to factor it. Sometimes things won't factor. So for instance, if nothing factors at all, then you're done. So like on this, if the top didn't factor and the bottom didn't factor, then I'm already in simplest form. Okay, it's not solving, it's just simplifying. However, in this case, x plus 7 doesn't factor, but I'm going to put parentheses around it to remind myself, hey, that's a set, it goes together. There's implied parentheses in the denominator. And same thing in the numerator. There's parentheses around this, but I can simplify this. I can factor it, I mean. Okay, two things that multiply to make negative 21 and add to 4. Well, if you're good with your factoring, you know that that's x plus 7 and x minus 3. Right? And now if you're not good with your factoring, then that's something you're going to have to brush up on, because that's an assumption I'm making right now. Okay? This cancels this. Or I can cancel up whole pieces. Okay, x plus 7, x plus 7. I'm left with x minus 3 on top, and just 1 on bottom, so that 1 by 1 is itself, so it's just x minus 3. All right, let's try one more here. Notice on this one, factor the bottom, and it becomes difference of 2 squares, so x plus 7 and x minus 7. I realize I'm going kind of fast, but maybe pause it, try it on your own. Okay, and then factor the top. Two things to multiply to make 49 and add to negative 14. Well, that would be x minus 7 times x minus 7. A lot of 7s here. Okay, well, the minus 7, well, this minus 7 can cancel that minus 7. Still have a minus 7 and a plus 7. On top, x minus 7. On bottom, x plus 7. Now, note, I have x's on top and bottom. I can't just cancel those. Remember, there's implied parentheses here. In order to cancel anything on top right now and anything on bottom, I have to take both pieces. And since there's an addition here and a subtraction here, you can't do anything with that. You have factored this. There's nothing else you can do. You can't get rid of the x's, can't get rid of the 7s. We are done. Okay, so that might be something to make a note of, and that's a common mistake. Students will just cancel out those x's and say, well, it's negative 7 over positive 7, so that's negative 1, and that's not correct. Okay, you'd have to have the exact same thing. All right. Let's try another one. Let's try to actually deal with some products here. Let's multiply. So just a reminder, if you were to pause it right now and try to multiply two fractions together and see how you do. You'd point out a bunch of misconceptions you might have. So a quick reminder on dividing or multiplying fractions. First thing you should always do is, well, I'm going to say the second thing. The second thing we are going to do is reduce. I'm only saying the second thing because there's another thing we do first when you have actual rational expressions. But without the variables, first thing we do is reduce. So 14 and 8. What goes into both 14 and 8? Well, 2 does. 2 goes into 8 4 times. 2 into 14 7 times. 12 and 35. What goes into both of those? Well, nothing. However, what I do know is that I can cross cancel. That's the next thing. Cross cancel, which some people call it cross reducing. Any top and any bottom. So I'm going to go diagonal now. 7 and 35. Well, 7 goes into 7 once and into 35 5 times. 4 and 12. 4 goes into 4 once and 4 goes into 12 3 times. So I'm left with 1 times 3 and 1 times 5. Now granted, you could go 14 times 12 and 8 times 35 and then reduce, but you get much bigger numbers and much more complex to do. Okay, so it's nice if you reduce and then cross cancel and then multiply. Okay, same thing goes when you're multiplying rational expressions. If you can first, number one is actually factor the top and the bottom, and then reduce each fraction and then cross cancel, and finally multiply the last step, then it makes your life a lot easier. So first thing I'm going to do, I'm going to look at all the numerators and denominators. Can I factor? Well, it's as simple as saying, first, do I need a factor? Are there any addition and subtractions? And there is not. So the second step is to reduce. Okay? And when I reduce, I'm just going to look at individual fractions. 10x to the fifth times y squared over 2x y to the fifth. So let's deal with the numbers. 10 divided by 2. Well, 5 goes into that, or 2 goes into that 5 times, and 2 goes into this once. So I'm left with 5 over 1. x to the 5th and x. Well, I have more x's on top. How many more? I have 4 more on top. So I have x to the 4th on top, and the x on the bottom cancel. Y squared and y to the 5th. Well, I have 2 up here and 3 or 5 down here, so I have 3 more on the bottom. So we're going to call that y to the 3rd left on the bottom. Okay, that becomes a 3. That one cancels. All right, let's shorten up that fraction bar. Now let's go ahead and we'll switch up the colors, and we'll deal with this 9/5. Well, 9/5 does not reduce x to the 7th and x squared. Well, you have 7 here, 2 here. Okay, so that becomes a 5th power. Y cubed and y. Well, you have 1 here and 3 here. You have 2 more. You do on bottom. Remember, really, all you're doing is subtracting those numbers using that property. Okay, and then I'll look at, now that I've reduced both, I'll look at cross-canceling. Okay, well, 5 and 5, those cancel. X to the 4th, well, nothing. Y cubed and y squared. Well, I have 2 here and 3 here. I have 1 more down here. So this is going to, this is going to become y to the 1st, and this just cancels. Okay, and nothing else I can do there. So now I multiply straight across. X and x, I have x to the 9th, and then just 9. So 9x to the 9th, and looks like just y on bottom. And we are done. We don't have any, we only have x's on top, only y's on bottom, and one number. So we're good to go. All right. Well, let's switch it up here. Let's try our next one. Can we factor? Well, I look at it right away. I see that this becomes x plus 4, x minus 4. It's difference of 2 perfect squares. This becomes x plus 10, x minus 9. This I can take a 2 out of. I then have x squared plus 14x plus 40. And then it looks like I could reduce that, right? That would become 2 times x plus 4, x plus 10. All right. Well, let's see, what else do I have? Anytime you see a negative, like a 9 minus, it looks like it's in the wrong order, always try to take out a negative sign. So if I take out a negative, negative what times, just like negative 1 times what is 9? Well, that's negative 9. Negative 1 times what is negative x? Well, that's positive x. So it allows you to switch the order there when you pull out that negative. It switches your signs. And by doing that, if you don't get that concept, you should really ask your teacher. Okay, by doing that, what ends up happening is I can end up canceling, right? So let's reduce first. Reducing there. I can get rid of the whole piece. Cross cancel here. Cross cancel here. Okay, so on top I now have negative 2. On bottom I have just x minus 4. So that whole mess we had just became negative 2 over x minus 4. And just so you know, what we'll end up doing is we multiply these, so we're simplifying so we can eventually solve equations. This would just be like one step in solving an equation. All right, let's go ahead and try one last one. I'm multiplying here. So this one here looks like we got a lot of factoring to do. Okay, so I'm going to first start by taking out a 7 here. 7, that gives me x minus 8. This one here I can factor as x minus 7, x plus 7 and x minus 1. Okay, and this one right here, it looks like becomes x minus 8 and x plus 7. Okay. And this one right here looks like we take out a negative symbol. Anytime a is negative, make it positive by taking out a negative. So negative, and we'll go, in fact, I can take out a negative 14, it looks like. Okay, so that's going to give me x squared minus 20, or minus 2x minus 1. Okay, and with that, or that'd be plus 1, I guess. With that, then I can factor this. This becomes x minus 1 times x minus 1, and we have our negative 14 up here still. Okay? And so from there, looking at reducing, let's go ahead and switch up colors here. Looking at reducing, I can cancel x plus 7 and x plus 7. Cancel x minus 8 and x minus 8. Negative 14 and 7 actually reduces. That becomes a 1. That becomes a negative 2. All right, and I can cancel x minus 1 and x minus 1. So really, looks like all I have left is negative 2 times x minus 1. Now, one thing that some students have a hard time with, this gets really messy, so sometimes it's helpful to rewrite it down below. Okay, if that'll help you out. All right, so hopefully you're good at factoring. That's a key piece here. Okay, let's go on to dividing. Dividing really is similar to multiplying. All you have to do is change its multiplication first. So your rules still apply. I mean, you're still, number 1, factor. Number 2, reduce. 3, cross cancel. Okay, and then 4, multiply. But before you can do any of that, change to multiplication. Change it to multiplication first. And the way we change it to multiplication, remember, is when it says find the quotient, it could be same thing as multiply by the reciprocal. Okay, so this, we have our first fraction, 18xy to the 4th over 5x squared y squared, multiply by the reciprocal. Okay, so when I say multiply by the reciprocal, we change this to multiply and we take the reciprocal of the back. I'm actually going to show that in a separate piece here, a separate line. So 18xy to the 4th over 5x squared y squared times the numerator becomes the denominator, and the denominator becomes the numerator. So this moves up, okay, and that moves down. All right, now I'm just into a multiplication problem, right? So don't change the front, don't touch the front, change that to multiply and flip the back. Okay, so from here, now I'm just looking at, well, reducing 18/5. That doesn't change. Okay, x and x squared. Well, there's more x's on bottom. There's one more on bottom than there is on top. So I'm left with just x on bottom here. Y to the 4th and y squared, I have more y's on top than I do on the bottom. I have 2 more. All right. So to kind of stick with what, oops, that was not what I wanted to have happen there. Okay. To kind of stick with our theme, if I can actually do it here. There we go. Okay, we'll change that to a 1, right? Go back to our color here. This is becoming more of a process than I thought it would. There we go. Okay, and now reducing here, 9/6 becomes 3 over 2. X to the 5th over x to the 3rd, well, you have 2 more on top than you do on bottom, so those are gone. This becomes a 2. Y to the 6th and y, you have 5 more on top than you do on bottom, so that becomes a 5. That was one ugly looking 5. Okay, so we get y to the 5th. And so then looking at reducing, cross-canceling, okay, I've reduced, let's cross-cancel. Well, 18 and 2. So I'll switch up the colors again here. 18 and 2, that becomes 1 and 9. Y squared, no y's on bottom. X, well, there's an x to the first, and here's an x squared. So this x squared actually becomes an x to the first, not an x to the 1/2. Okay, and so it looks like we're done. We've got 9 times y squared times y to the 5th and an x. So we have 9, well actually 9 times 3 is 27. X, y to the 2 and 5 is 7 over 5. There we got it. All right. Well, let's try the next one here. All right, first thing I'm going to do, change it to multiplication. So I need to go 5x over 4x minus 16 times, we'll flip the back, x squared minus 7x plus 12 over x squared minus 3x. Okay, and now it looks like I'm going to factor, so we'll switch it up here. Okay, I can't factor 5 times x, already done, but this one I can, the 4x minus 16 could be 4 times x minus 4. This right here, looks like we can go x minus 3 and x minus 4. And this x squared minus 3x can become 3, no it can't, it could become x times x minus 3. So, from there, it looks like I could do some canceling. I can cancel, or I can look to reduce. I can reduce there and there. I can cross cancel here and here. And that x and that x. Looks like I have 5 on top. Just 4 on bottom. 5 fourths. The whole mess becomes just 5 fourths. Who would have known? Well, I did. I have the answer key. However, I mean, who knew? You know. All right. This last one, let's change the multiplication first. So we got x minus 8 and x squared minus 2x minus 48. I hope you guys are pausing and trying to do it on your own here. Flip the back. We have 4x squared plus 40x and x plus 10. Okay, I'm trying to look a little cleaner there. Okay, we'll go ahead and do some factoring. So that's already factored. Can't do anything with it. This right here looks like becomes x minus 8 and x plus 6. Looks like right here we can take out a 4, x, and left with x plus 10, and x plus 10. All right. Pretty convenient. Let's reduce x minus 8s, x plus 10s, cross canceling. Doesn't look like we do any cross canceling. It looks like we're done. On top we have 4x left. In the denominator we have x plus 6. Now remember, I can't cancel the x's because x plus 6 is tied together with parentheses. You have to take out the whole x plus 6. So we are done. All right, well, I think only have one piece left, and that is multiplying and dividing rational expressions by a polynomial. And really, this is the same stuff. It just, you got to remember, anytime you, like if we were doing, say, 3/4 times 7, right? If we had 7, well, we just put a 1 under it, and then we'd multiply. Well, that's the same thing you do here. You don't have a fraction, you just put a 1 under it. And now you go on to multiply. Okay, you do the same thing. We got to factor. Now we're already multiplying, so we don't have to do anything with that. So we're going to factor, right? So x plus 3 can't factor. This right here does, though, however. X squared plus 2x plus 4 becomes, oh, no, it doesn't. Oh, man, what do we do? Well, we got x cubed minus 8. Oh, x cubed minus 8, that's a perfect, that's perfect cube. That's 2 cubes. So if you don't remember that pattern, let's do a quick reminder down here. Difference of 2 perfect cubes. Okay, and so let's say we have a cubed minus b cubed. We have a perfect cube and a subtraction sign and a perfect cube. Remember that factoring becomes a minus b times a squared minus ab, or excuse me, plus ab plus b squared. So I'm not going to go through how we come up with that pattern because I've taught it before. I think in the textbook we're using it's like 4.4 if you want to look back in your notes. Or, you know, do a search on it and kind of explain it. Or you can ask the teacher in class and they can kind of walk you through it again if you really want to go through the process. But the other would be, actually we'll call it good there. Okay, difference of two perfect cubes. All right, so when I look at this perfect cube and perfect cube, I'm going to rewrite what I have here. I have x plus 3 on top, and then on the bottom, that x cubed, well, if I take the cubed root of x, I get, or x cubed, I get x. And the cubed root of 8, I get 2. Because 2 times 2 times 2 is 8. So that's going to be x minus 2. That would be like my a and my b, right? If you're thinking of it like this, x cubed is my a and b is my 8 there. Or I guess we'd have to think of b as my 2 cubed. Right? So there's my perfect cubes. All right. So make a note. I don't know how it would be best to explain it for yourself, but think of this as a and that as b. Okay, and then so I have this piece. I now need to have a squared. Well, if a is x, so that would be x squared minus or plus ab. Okay, so I have 2 times x, 2x, and then b squared. B squared is 2 or negative 2, so we get positive 4. All right, so that is that whole first piece right here. That chunk became this. Times, and we have our x squared plus 2x plus 4 all over 1. Now I can't factor this, however, notice this x squared plus 2x plus 4 is the same as this x squared plus 2x plus 4. So they can cancel, they can cross cancel. And I'm left with, I can't reduce anything else. So I'm left with x plus 3 on top, this one right here, and x minus 2 on bottom. And remember, I can't cancel x's. These are like package deals, right? They go together. You have to take the whole thing with it. So that is my solution. I have now simplified it. All right. Let's try one more here. We're dividing. All right. So first step in division is rewrite it as multiplication. I'm going to put a 1 under that first, right? Okay. Over 2x squared times, and this gets flipped. We flip it around. So now 1 over 3 minus x. Okay. So it's 15 minus, or 15x squared minus 2x. Well, two things that multiply to make negative 15 and add to negative 2. So for those of you that use this method, multiply to make negative 15, that times that, and add to negative 2 are negative 5 and positive 3. And then always divide by your 15, divide by your a term there. Okay, and then we'll reduce this. This becomes negative 1 over 3, and this becomes 1 over 5. Okay, so I'm left with now the denominators come out front, so we have 5x plus 1 and 3x minus 1. So notice your denominator goes out in front. The minus 1 is your back number. Denominator goes out front. The plus 1 is the back number. So that factor's there. Okay, and then 3, actually not 3. Looks like x comes out of that. 3 minus 1. Not 3 minus 1, my goodness. 3x minus 1. So x times 3x is 3x squared, and x times negative 1 is negative x. So you take an x out of both of those. All right, so it looks like from there I need to do some reducing. So let's go ahead, get rid of the 3x minus 1. And it looks like that's it. So on top I'm going to have 5x plus 1. On bottom I have 2x times x, or 2x squared, excuse me, times x, which is 2x cubed. And remember, I can't cancel the x's because this is a package deal on top. You have to take the whole thing. All right? I think that's it. Okay. That's all I got for you, I think. Yep. Good luck.